It's probably it's definitely wrong. Okay.
Yes.
I was,
Yeah. At least I can understand what you're doing.
Three on the outside and the square.
Well, that's true. Pies don't matter.
4 times 3.
You what? No, they kind of matter.
I'm guessing.
Subtract.
Which one?
Subtract.
The 343 times. Wait,
Wait,
so
oh, really?
times the square root.
Wait. Is that 3?
I think.
This
This is
one
one
has
more.
10 types of one.
Not gonna be 3. Yeah, we can 4 to be 5.
You say 7 squared.
That's what you're doing.
So it would be 4.
What are you talking I'm grateful.
All right, let's take a look at what you got.
You just want the time.
All right, first one. 3 square root of 2 times 3 square root of 2. Add exponents. Radical 2 plus radical 2 would give you 2 square root of 2. And we're just going to leave it like that. That's how they want that answer. Okay, 3 square root of 2. For 24, you got to get a common base. So 49 can be written as 7 squared. Those can be multiplied, power to a power. And then so you end up in square root of 12. Sorry, I forgot to say. We need to rewrite that as 2 radical 3. And so the power to the power will give me 4 radical 3. Add those together. 1 plus 4 gives me 5. So it should be 7 to the 5 square root of 3 for 24. For 25, now, some people ended up with this answer, but you got to be careful because you can't just say 8 divided by 4. In other situations, that won't work. So if it was something other than the same exponent, so you just got to be careful. You cannot do 8 divided by 4. We got to make 8 2 cubed. Then that's 3 pi. 4 is 2 squared. That's 2 pi. And then you subtract. 3 pi minus 2 pi will give you 1 pi. That's how we get 2 to the pi. Okay, there. You got to be careful. Like I said, it worked in this situation if you just said 8 divided by 4 is 2, but that won't work in all cases. 26. Again, we got to go to the same base. 27 and 9 can both be written as base of 3. 9 is 3 squared. 27 is 3 cubed. And now you get 2 square root of 5 over 3 square root of 5. Subtract, you get negative radical 5. And I'm going to write that as 1 over 3 to the square root of 5. Okay, for that. And then the last two are not nearly as difficult, I don't think, because all you got to do is multiply those two together. You don't have to change any bases. 3 to the square root of 6, 2 to the square root of 15. Okay, for that. All right, I wanted to hit those because we did a couple of those like that in the notes, so I wanted to cover that again. All right, we need to finish the graphing from the notes, and then we're going to start that second page. We won't get through all these notes that you will see here, but I will spoil your day and say there is homework. I know. But this is a long section. It used to be 2 sections. They combined it into one. And so it'll take us some of today and then part of tomorrow as well. All right, on the back of that first set of notes. All right, we did not get to this at all, did we? On the very back, we didn't talk about it. All right, just a quick rundown of your transformations. I think you're pretty familiar, but I'd at least like to cover it again. Whoops. The blue one here is your parent function. And so what do I have to do to my equation to get it to reflect across the y-axis? So you got g of x on top there. So there's your 2 to the x. Alex, you remember what we need to do to that to make it reflect?
Negative 2x.
Not in front of the 2. Actually, the negative is going to go.
Negative is not equal to x.
Hold on. No, we want to go actually 2 this way. Now, what you're talking about, that'll be the next phase. All right, so if it reflects over the y-axis, that's where you negate just the x. Okay, basically, wherever 3 is, we're going to, boom, flip it over to negative 3. Wherever 2 is, we're going to flip it over to negative 2. So that's kind of one way to think about it. So you'd have 2 to the negative x. For this case here, again, this is our, hold on. That's f of x equals 2 to the x. If we reflect it over the x-axis, you see there you got h of x. That is where you negate the entire function. You just put a negative out in front, and that's going to change your y value from positive to negative or negative to positive. So it's going to flip it over the x-axis for that. All right, that next set, the only reason I got that dotted line there, it's obviously not a horizontal asymptote. It's just to show where or how it's being moved. You got the one in the middle, which is our f of x equals 2 to the x. It's just being shifted to the right, and it's being shifted to the left. And it's being shifted 2 units. Well, if I'm going to shift it left and right, so I'm going to work, let's use this first one over here. I'll call that g of x. Remember, you got to add or subtract something. So in this case, if it's moved to the left, we actually do what? We actually add, but what do we add it to? You got to add it to the x. So you got this power here. So you want to make that x plus 2. Because here's what's happening. 2 to the 0 is 1, right? 2 to the 0 is this point right here. All right, how do I get an answer of 1? You've got to make this 0 as well. Well, what's going to make that 0? It's going to be negative 2. So that's how when I plug in negative 2, I get back that same y value as when I plug in 0. You basically see what's going to make that get 0 as well on top. For the red function, we'll call that h of x. That's going to be 2 to the x minus 2. So if it's moved right 2, we subtract. If it moves left, you add. And it has to be in the power. It has to be in the power. All right, this one's been moved down. Again, f of x is 2 to the x. G of x is going to be 2 to the x minus 3. And that minus 3 cannot be in the exponent. I mean, it has to be just separate. You're going to subtract 3 to lower it. Now, in this case here, I am going to draw in that horizontal asymptote to show you that it clearly has a floor. It does not go below that. What do we do when we have multiple transformations? This doesn't change. You got horizontal shifts first. You got stretch or compress second. You got reflections third. And then you got vertical shifts fourth. So you got your high school RV. That doesn't change. All right, once you get that, let's take a look at this equation here. Y equals 2 to the negative x plus 2. And we'll graph, that would be that A there on the bottom. I'm going to graph the parent function, the 2 to the x, on here just so I have it. I'm going to make a quick table, which we did on the front, but that was on Friday. So that's been a few days ago. So x, y, I'm going to plug in negative 2, negative 1, 0, 1, and 2. All right, 2 to the negative 2. Positive 1/4. 2 to the negative 1. Positive 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. So negative 2, I get 1/4. Negative 1, 1/2. 0, 1. 1, 2, 2, 4. So it looks like that. All right, as you look at the second equation, y equals 2 to the negative x plus 2. All right, what's happening? As you take a look at that, what transformations are going on? Ben, any horizontal shift?
Horizontal shift. No. Or yeah.
Which way?
Left.
Left,
2.
left 2. And then what else? Any stretch or compress?
No.
What about reflection?
Reflects over the y-axis.
Okay, over the y-axis. So those are the only two things that are going on. Left 2 over the y-axis. I'm going to start with my given points, and I'm going to move them left 2 and reflect over the y-axis. So for 2, 4, left 2, when it reflect over the y-axis, it's on the y-axis, it should be right there. Now, the one good thing when I have the equation is you can test your point to make sure you're right. So if I plug in 0, will I get back to y value 4? Yeah, because that's going to be basically cancel out and give you 2. 2 squared is 4. All right, I'm going to take this left 2. And what happens here when I go left 2 and I reflect it over the y-axis? I end up right back where I was. Okay. And now I'm going to take 0, 1, left 2, and I reflect over. So I get 2, 1. I got negative 1/2. I go left 2 to negative 3. Reflect over to positive 3. And then I reflect over there to 1/4. And then draw that in there. So that would be that case. Left 2, reflected over the y-axis. Flip it the other direction. All right, horizontal asymptote will still be the same. All right, second one. All right, take a look at negative 2 to the x minus 1 minus 3. All right, again, I'm going to put the base function, the parent function on there, y equals 2 to the x. I think what's happening to this one once you get it written down. I'm not going to draw out the XY chart for the 2 to the x since we did it on the last one. All All right, Carter, what we got going on? What do you think?
Down 3.
Let's start with horizontal first.
Well,
Start with the H. You're right, it does go down 3.
right 1.
Okay, x minus 1 gives me right 1. Agree. All right. What about the negative in front?
Is that over the x-axis?
That is going to be over the x-axis. Okay, so it's going to reflect over the x-axis. And lastly, it will go down 3. Now, when it moves up or down, I am going to put in the horizontal asymptote because it will either be a floor or a ceiling. Like it won't go below it or it won't depend on how it's shifted. It won't go below it or it won't go above it. So take a look at your, I'm going to pick the point 2, 4. And I'm going to go right 1 to 3, 4. Over the x-axis takes me all the way down to negative 4. And then I go down 3. I get the point 3, negative 7. All right, plug 3 into your function and see if you get back negative 7. Just to do a quick check, make sure you did it right, either on your calculator or mentally, whatever you need to do. But test that point because we do have that equation. You agree? What'd you do? Oh, okay, when it's written like that, the negative is not in parentheses, right? So it's 2 squared with negative in front. So that'll stay negative 4. Okay. All right. So when I plug in 3, you get negative 2, 3 minus 1, minus 3, negative 2 squared minus 3. Now remember, the negative is not in parentheses, so you just square the 2, gives me negative 4 minus 3 is negative 7. What next point? 1, 2. Move right 1, reflect down to negative 2. I'm going to go down 1, 2, 3. And then I got 0, 1, go right 1, reflect over to negative 1, go down 3. And then I go right 1 with negative 1 1/2, down, reflect over to negative 1/2. And then I'll end up going to negative 3 1/2. And then the same thing here, negative 3 1/4. That will be my ceiling. Won't go above it. And then I got those 5 points. All right, once you're done with that, we're going to go to that next set there. The one thing about this section deals a lot with, I forgot one thing. Not that you have to write this down. On page 427, okay, it just gives you a quick summary of what we just went over, like how you change the equation to get the different transformations. Horizontal shift, you add a constant to the exponent, okay, plus or minus b. Okay. Vertical shift, that is where you add a constant after like the 2 to the x. Stretch or compress, that's when you're going to multiply. On the outside will be vertical. If you multiply the x by a constant, it'll be horizontal. And then what is the last thing? Reflections. Okay, again, a negative out in front will reflect it over the x-axis. A negative with the x will reflect it over the y-axis. All right, you're starting to get to the point where some of you got jobs, some of you get a little more aware of finances. You're thinking about college. You're thinking about different things. And so this is a really good section to kind of teach you a few things about, cars and houses and how things either appreciate or depreciate their values. 2 things: simple interest, compound interest. Which one's better? Anybody know? Compound. Compound is a lot better. Most things are not calculated with simple interest. It's just kind of how we introduce things. So on the top there, you see those guide notes where it says simple interest principal. That's your initial amount. Go ahead and put down $5,000 underneath there. The rate, 4%, and then the time will be 3 years. Under this scenario, how much interest will be accrued? Well, the interest will equal the amount, which is 5,000, times the rate, which we always write as a decimal, 0.04, times the time, which is 3 years. Use your calculator, multiply that together. That gives us the interest. Cam, let me know what you get.
600.
600. Yeah. Probably got like 0.5 right now.
0.0 something.
0.0 something. 0.01. Yeah. Not very good.
I get 3 points.
Now, so in the end, you'll have 5,600. Now, a quick scenario of compound interest. You can really take interest at any interval you want. You take that interval, you take that interest, you add it back into the principal. If we waited for the end of 3 years, we got $600. Let's take the interest after each year. Okay, we're going to take it 3 times. So after year 1, okay, the interest will be the principal times the rate. Now the time is now 1 year. We're taking the interest after a year. So what is 5,000 times 0.04 times 1? Okay, what is that going to amount to? That is 200. What you do is you take the 200 and you add it to your initial 5,000. So now it becomes 5,200. So after year 2, so you got to think, so your total, I'm going to put it over here, will be 5,200. That's your total. After year 2, your interest will now be 5,200 times 0.04. Again, times 1, because it's been 1 year since you last took the interest. Okay, so the time will be the amount of time between the times you take the interest, you calculate the interest. So it's 5,200 times 0.04 times 1. Is it 208? That's 208. So what's my total now? My total now is 5,408. So after year 3, so now my interest will be 5,408 times 0.04 times 1. Again, 1 year between the time we last took the interest. Anytime you're dealing with money, round to the nearest cent. If it doesn't work out to a whole number, okay, nearest 100. So what do we get, Gabby, for that?
216.
And how many cents?
32.
32. So I'm going to add that. So now I got a total. Add that to the 5,408. So I get 5,624.32. So in this very simple scenario, if you just take simple interest at the end of 3 years, you get $600. But here, if you do compound every year, you get 624. 24 may not seem like a huge amount. It's not, obviously, but if you're a company like Amazon, instead of $5,000, you probably have 500 million in an account. And if you compound that instead of $24, that might amount to $1 million or millions of dollars. So it does play a role based upon the amount and the length of time. There is a formula to calculate compound interest. We don't have to do this year by year. All right, here is this formula. This is what you need to put down there. P is your principal. Now, interest can be negative if it's like an interest on a credit card. So you made for Christmas, you really wanted to impress your boyfriend, and so you bought him $6,000 worth of gifts. Now you have to pay it off. So if you don't pay it off, you get interest charged to you. There is no fixed number of times that you can compound it. So you can compound it once a year, 4 times a year is what we call quarterly, and you can compound it monthly, you can compound it every day. Okay, so for a couple things, so if n equals 4, that's compounded quarterly. That's how that's referred to. If n equals 12, compounded monthly. And let me go back up here, and n equals 1 would just be compounded annually. Okay, for that. But those are the common ones. All right, let's take a look at a couple scenarios here. All right, first one. Find the accumulated value of an investment of $2,000 for 10 years at a rate of 7% if the money is compounded quarterly or compounded monthly. The more times you compound it, the better. Okay, so compounded monthly will give us a little bit more than compounded quarterly. You need to calculate the exact value to the nearest penny for each of these. So we're going to use that formula, A equals P times 1 plus R over N to the NT. For the first one, N equals 4. For the second one, N equals 12. The only thing you got to watch is just entering in your calculator. There's a couple of mistakes you can make, and if you have one of the newer models, it really takes it away because if it just automatically kicks it up to the exponent, then you don't have to worry about it. If you got one like I have on the screen, you got to be careful with a couple things. So the amount will be $2,000 times 1 plus 0.07 divided by 4 to the 4 times 10 power. If this is a small enough number, go ahead and multiply those together. So 0.07 divided by 4 to the 40th power. All right, use your calculator, figure out what you get, round it to the nearest penny. All right, everybody do that just to make sure everybody enters it correctly. We all get the same thing. Don't just wait for me to write the answer down.
I did that.
What card? Okay, there we go. Yes. Okay. All right. Justin, what'd you get?
$4,003.19.
Okay, $4,003.19. All right, a couple things you just got to be careful of. Number one, and most times you're not going to do this, but every now and then I see this. When you got this in parentheses, the 1 plus 0.07 divided by 4. Don't try to break this up into piece by piece. Do the whole thing at once. One thing you don't round off. You round nothing off to the very end. Because if you change this to 1.02, it's going to drastically change some of your answers. So do not round that off. Second thing, like I said, if you got one of these models, if I type in 1 plus 0.07 divided by 4, and I type it in to the 4 times 10 power like this, okay, it gives me that, 21,437. Okay, that's a lot better, isn't it? Yeah, but it's wrong. What's my calculator doing wrong? It's doing order of operations. It's taking it to the 4th power and not the 40th. And then it's taking the answer times 10. Like some of your newer ones, it automatically puts it in the little box up there. You don't have to worry about it. If it doesn't, you either need to multiply it by hand or put those in parentheses. So I can make this 1 plus 0.07 divided by 4 to the 4 times 10. If you do that, that'll take care of that problem. So just be careful. All right, go ahead and figure out what compounded monthly if you haven't already. Okay, to the nearest penny, compounded monthly. What do you got? Oh, you did. Okay, just right from there, take the whole thing in, just as it is. So it's 2,000. That would be 2,000 parentheses 1 plus 0.07 divided by 4 to the power 40. Yep. Now, this should have been 2,000 times the answer right here. That's why that went wrong. And this, you did have to multiply that. That would have been right if you multiplied it by 2,000. The 2,000 goes with the P, where the P is. That's why. Sorry, I didn't see that. Okay. Kyle, you got it?
Yeah.
All right, hold on here. Let me write this out. A equals 2,000. 1 plus 0.07 divided by 4. No, 12. You're right. Thank you. 12 to the 12 times 10, which would be 120. And then what'd you get for your amount?
$4,019.32.
32 cents. Okay. So you get a little, 16 extra dollars. You can get a large pizza. Okay. In the end. So monthly will give you more. It's not going to give you infinitely more, okay, but it'll give you more. And it adds up over the course of months and years, okay, for that. All right, second example here. The two main things that affect it are the interest rate and the number of times it's compounded. Okay, they don't affect them equally. Okay, so we want to compare the differences here between 10% compounded monthly or 8.25% compounded daily. So for the first one, you got 10% since it's monthly, n equals 12. The other one is 8.25%, n equals 365. You always use that for daily. You don't say it's a leap year and make it 300, just 365. Okay. So it's always going to be that for daily. All right, now we do the same thing. I want you to list both amounts that you get. Compare the two. Don't just say one's better than the other. I want to list the amounts. So we got to type them in. We got 25,000 for 3 years. So A amount equals 25,000 times 1 plus 0.10 or just 0.1 divided by 12 to the 12 times 3 power. And I'm going to write out the other one as well. 25,000 times 1 plus 0.0825 divided by 365 to the 365 times 3 power. All right, figure out what each of them are to the nearest penny. Ashley, you got the first one?
Yeah.
What you got?
33,704.55.
All right, so we got that first one. And Emma DeLuca, you got the second one? Anybody got it? What you got, Alex?
32,019.59.
That right? 30,019?
Yeah.
Okay. All right. Obviously, which one gave us more? 10%. the interest rate will have a greater bearing than the number of times compounded. And the difference between 10% and 8.25 is pretty significant in terms of finances. Okay, so that's going to give you, in this case, almost $1,700 more than the other case. So you would definitely go with that. All right, look at the next one down there. It does not talk about compounded monthly or compounded quarterly, but this will still be, we can still use the compound interest formula for it. Anything that increases or decreases by a set percentage, we can use this. Now, there will be a minor change. So think about this. What would N, how would I use N, even though it doesn't say compounded monthly or quarterly or anything, but N would be a certain value. What would it be in this case? Because it's increasing a rate of 4.5% per what? Year. So N is what? 1. Now, look what happens to our equation when N is 1. So you got A equals P times 1 plus R over N to the N T power. That's our compound interest formula. But if N is 1, it just becomes P times 1 plus R to the T power. And N just equals 1, it just simplifies. So if you, anytime you have this case, it's really the same as a compound interest one, but we can just use P times 1 plus R to the T power. All right, you got the median price, $128,000. It's going up 4.5% per year. After 12 years, what's it going to equal? Before you type it in your calculator, make a mental guess. What do you think it's going to be? And then let's take a look at what it actually equals. So in this case here, my final amount will be, we'll be starting out with 128,000. 1 plus 0.045 to the 12th power. And even though you probably would never list the nearest penny for the value of your house, we're going to do this for this case anyway. Shayla, let me know what you get.
I got $217,072.82.
All right, so it increases. If it's going up 4.5% per year, okay, at the end of 12 years, you're up almost $90,000. Okay. All right, we got time for one more. We got to get this through this last one. Next one. Flip it over. Houses typically increase in value. What about cars? They decrease in value. You buy a new car. 2 years later, it's not worth the same amount that you bought it for. You cannot sell it for more than you bought it for. It goes down in value. So let's see how that is going to be affected by our equation. Sorry. This is it. So a $15,000 car depreciates at a rate of 9% per year. It's per year, so N is 1. Now the amount will be the principal times 1 minus R to the T power if it's going down. Subtract that rate. So over here, it's going to be, after 5 years, my amount will be 15,000 times 1 minus 0.09 to the 5th power. Okay. So this is the scenario. And some of you may have already looked into buying used cars. You look up the Kelley Blue Book value of what it is with the mileage and all that. So there's some, depreciation involved. Final amount. Tessa, you got it?
$9,360.48.
$9,360. And then what was the cents?
48.
48. We agree?
Yep.
All right, we'll have to talk about your grandma tomorrow. But there is a few problems.
Yeah.